Welcome to the World of Science Academy, where we do offer science and mathematics lessons. Alright, so in today's lesson, I want us to expose you to chemistry as one of the components of science. Okay, so now in today's lesson, like I stated, I want us to discuss how to calculate the percentage yield of a different compounds in the reaction. Alright, so here's the question that we're going to discuss today on how to calculate the percentage yield of the copper sulfate. So we have the question here. So 2.4 grams of copper metal were heated with excess sulfur to yield a 2.25 grams of copper sulfate. What is the percentage yield of this reaction? Okay, so now we have the equation here, which is copper in solid form, and then which reacts with the sulfur to produce copper sulfate. Okay, so this is the reaction. So the first thing that we're going to do is for us to calculate this percentage yield, we have got the formula. Okay, in that formula we have this one. Okay, so we have the percentage yield. Percentage yield is equal to the actual over theoretical multiplied by 100%. So here we are trying to calculate the percent composition of the element of a certain a certain compound in this reaction. And in this case, we are trying to calculate the percentage yield of the copper sulfate. Okay, so in this reaction, we have been given the actual amount in grams for copper sulfate, which is 2.25 grams of copper sulfate. So this one is what we call the actual, and then as we are going to calculate the theoretical amount of what we call copper sulfate, for us to calculate the percentage yield of this one. Okay, so what we're going to do is, the first thing that we're going to do is to calculate the number of moles of copper, and then we are going to use what we call the mole ratios for us to calculate the number of moles for this one, and later on we are going to calculate the grams of copper sulfate. So how are we going to calculate the number of moles for copper? Okay, so we have the formula that we use under the mole concept, of which we have as so this is the formula that we use to calculate the number of moles of a given compound. So we have the number of moles is equal to mass over the molar mass or the relative molecular mass of this compound. So now how are you going to calculate? So we're going to say that the number of moles is equal to mass of an element, which is copper, and we have been given the mass, which is 2.4 grams of copper metal. Okay, so we have that one as 2.4 grams of copper, and then we are going to calculate the molar mass. I mean the mass number for the same element called copper, of which it is there stated on the periodic table, which is the 4. And then from there we are going to do the computations there, and when we do the computation, we are going to have the number of moles is equal to 0.0 so we're going to have So we're going to have the number of moles as 0.038 moles. Okay, so this one becomes the number of moles for copper, and then of course we have got the reaction which is clear stated that copper reacted with the sulfur to produce the copper sulfate. We have now the number of moles for copper, but we do not know the number of moles for copper sulfate. Okay, so therefore we are going to say say that this one, we are now going to use the mole ratios, okay, for copper and the copper sulfate. So when you look at this reaction, it is a well-balanced reaction. Therefore, we are going to say that the mole ratios. Mole ratio, okay? So mole ratio, in this case, we want to calculate the number of moles for copper sulfate. How are we going to calculate? Because we do not have the gram of this one. So we are going to use the mole ratio, and the mole ratio here it is 2 to 1, because here we have got a coefficient of 1 there. So we are going to have 2 to 1, okay? And this one is the number of moles for copper, and copper here is 2. So we are going to say 0.038 to x of which we don't know. Okay, we are going to set to do the computation there, for which we are going to have 2x is equal to this one, which is 0.038. We want to calculate the number of moles for, we have to have the value of x there. So divide by 2, then divide by 2. And then this one and that one will go. We are going to have x as we have that one. So this answer, the same answer. Okay, so this one becomes the number of moles for copper sulfate. Okay, now that we have the number of moles for copper sulfate, then we can calculate the gram of this compound called copper sulfate. So we are going to state that copper, we have the number of moles for this one, which is 0.0188 moles. Okay, then we are going to use the same number of moles to calculate the mass for copper sulfate. So we have the same formula that we use. It is number of moles is equal to mass over molar mass. So here we are going to make mass the subject of the formula. Okay. So we are going to say number of moles is equal to mass over that one. Okay. So we are going to say that this one over that, of which we are going to have the mass is equal to number of moles multiplied with the relative molecular mass, which is n multiplied by that one. Okay. So from there we are going to say mass is equal to number of moles of course, which is that one, which is 0.188. 0.0188. Okay, then multiply by the molar mass or the relative formula mass for copper sulfate, of which is 160 when you calculate. Copper we have got as 64 as the mass number, and then multiply by the number of atoms of copper, which is 2, and then you add the mass number for sulfur, which is 2, and then we are going to have 160. Okay, so 160 there. So now what will happen is that mass is equal to, when we do the computation there, we multiply the 0.0188 multiplied by 160, we are going to have 4. Okay, so when we do multiply here, we are going to have, okay, so when we do when we tabulate this one, which is 0.0188, multiplied by this one, it is the mass number, okay, or the relative molecular mass for copper sulfate. We're going to have this one as the gram of this compound called copper sulfate. Now that we have the theoretical, then we can calculate the percentage yield of copper sulfate. So how do we do? I gave you the formula area of which is zinc. So the percentage yield is equal to the actual over theoretical. Okay, theoretical multiplied by 100%. Okay, and then we just plug in the formula of which we're going to say the percentage yield is equal to actual is the amount of substance that we were given. Okay, so in this case it was 2.25. Okay, over the theoretical, the one that we've calculated, which is 3.001 multiplied by 100%. So now what we're going to have is that when we do the integration here, and then we're going to multiply that number by 100%, and then we're going to say we've calculated there the percentage yield of this substance called the copper sulfate. Okay, so let's try to divide together this one by that one, and then we multiply together with that one. So when we divide, we're going to have this one. So we're going to have 0.7. So 0.74, 0.75. Okay, multiplied by 100%. So the same number multiplied by, so we're going to say answer multiplied by 100%. So we're going to say 0.75 multiplied by 100. So we're going to have 75 as our percent. So 75%. So this is how we calculate the percentage yield of element given an equation of which we are going to we use the mole ratios to calculate the percentage yield, and then the formula which is the percentage yield is equal to the actual over theoretical multiplied by 100%. On that one, we are going to record another one, and please subscribe to my